Hello students, welcome back to my YouTube channel. Today I will discuss an important question taken from electrostatics and based on the equilibrium of forces. A charge Q is placed at each of the opposite corners of a square. This is a square. Charge is placed opposite corner, that is corner A, and another corner B, opposite. This is the B. Side of square, consider A. A charge small q is placed at each of other two corners. The remaining corners, this and this, charge q. This is q, correct? This is A, B, C, and this is the D, okay? If the net electric force on q is 0, according to question, if net force on q, this is the q, this is the q, this is the q, net force on the q is 0, then q divided by q equals, we have to find ratio of capital Q and small q. What will be the value of q divided by q if force on capital Q is equal to 0? Okay. Now, this charge, force applied on this charge, repulsive. Force on C due to A, we can write CB, and direction of force towards this, okay, along the diagonal. Now, force applied by B on C away from the charge, because both charges is positive. If charges is positive, so force will be repulsive. Repulsive means that force directed away from the charge. This is the charge, away from the charge. Force on C and B, correct? Now, force applied by Q on C, F, C and D. This is the force on Q. Now, one force here, this is F, C and D. Another force here, this is F, C and B. And another force here, this is F, this is the F, CB. The net force, FR, the net force of this, magnitude of this force, K, capital Q, small q, divided by A square. Any doubt? This force, CD, CD force, K, capital Q, small q, divided by A square. And force CB, K, capital Q, small q, divided by A square, correct? And force of this charges, K, q into q, q square, divided by a root under 2 square, correct? Now, this is the diagonal, and diagonal equal to a root 2, correct? This is a and this is the a, so diagonal will be a root 2. Now, FR equal to resultant of this force and this force along also this force. FR, resultant of this and this, we can write F CD square plus F CB square, correct? Now, KQ divided by A square, also KQQ divided by A square. We consider F and we consider F. So F square plus F square is equal to 2 F and root under 2. Okay? Resultant of this vector and this vector along this. And CB is also in this direction. So net force, F net is equal to FR plus FCB. FCB. FR, F root 2. F root 2 means F root under 2 plus FCB. Now, F root 2 means KQ divided by A square root under 2 plus FCB KQ square divided by A square root under 2. Now, F net means that total force on Q. Total force on Q according to question. If the net electric force on Q is 0, according to question, this is 0. Now we can solve K, Q, root under 2 divided by a square equal to minus k q square divided by a square. This is a square, sorry. This is a root 2. This is a root 2. See, a root 2. This is the a root 2. Now, sorry. kq square a square 2, that is we can write a square into 2. A square of root 2 becomes 2, so kq square divided by a square into 2. Okay, k and k, capital Q, one capital Q, a square and a square. Here becomes a small q root 2, here becomes q divided by 2. So we can write a small q root under 2 is equal to minus q divided by 2. We have to determine capital Q divided by a small q. Capital Q divided by a small q. Now, q root under 2 equal to minus q divided by 2. Capital Q divided by a small q equal to minus 2 and root under 2. Correct? The value of capital Q, a small q is equal to minus 2 root 2. This is important question taken from equilibrium. This question asked in JEE Main 2009. Correct? Please subscribe to my YouTube channel, share the video and like it. Thank you.